Good evening, everyone. Myself, Ashu Sharma. I welcome you all in series of operating system lectures. Today, we will see SRTF, shortest remaining time, first algorithm, and we will solve one question over that. Before that, we have covered two techniques which were based on a non-primitive scheduling algorithm. First one was FCFS, first come first serve, and second one was STF, shortest job first. Now, today, our topic for discussion is SRTF. So SRTF having that one of that condition where we have to find out that first time, having that minimum time for given, and the process is going to be in prioritize which having that less was time. So we will see one of that numerical on that. These topics are important for GATE and as well as for your competitive exams. So and for your university exams as well. So you have to practice at home and definitely you will be able to solve these all the questions. So let's I share that whiteboard and then start by solving this numerical. So here we have this question that is based on that SRTF. SRT, which is primitive version of algorithm scheduling, primitive scheduling algorithm, to sort of this using that techniques and find out that completion time, response time, waiting time, as well as turnaround time. So it's shortest time cost. So before going through this, you have to cover previous two lectures as well. So in those lectures, you have to practice solving these numericals and then come to this video. So it will be more beneficial for you. Now for this given algorithm, we have a query and the questions to solve is having these P1, P2, P3, and P4 process, and yeah, arrival time is also given. So arrival time is having 0, 1, 2, and 4, 0, 1, 2, 4, and their was time is also given is 5, 3, 4, 1, 5, 3, 4, 1. So this is given in the question. And firstly, as we always prepare Gantt chart. So starting with the Gantt chart and try to sort out this. So having this Gantt chart. Now see, very first we have to look for the arrival time. Arrival time is 0 for P1, and it will first that come into the CPU and execute for 1 unit time. We take 1 unit at a time because of rest of the process. If anyone can come with the smaller burst time, we have to give priority to that process. For that purpose, we start with P1, and it is from 0 to 1. And at that 1, here we have this arrival is 0 to 1 for 1, and this burst time becomes 4 because one unit execution already completes for P1. Now for P2, here we have this process 1, P2, and having this arrival time 1 and burst time 3. So it is minimum uh, among all the given process because P1 having 4, P3 having 4, and P4 having 1, but arrival of P4 is at 4 unit time, so we will take this P2, and P2 will run 1 to 2, and then again its burst time decreases by 1 factor, so it will become 2. Then we take P2 2 to 3, then P2 3 to 4. So this is the way that P2 completes its execution for 3 unit time interval, and it will exit CPU. At 4 unit time, P4 will come because P4 arrival is 4 unit and it's having that less was time. So you have to put this P4 over here and it becomes 5. So P4 also completes its execution and exits from the CPU. Now we left with only P1 and P3 because P2 and P4 are already done. So as here that burst time is equal because 5 decreases up to 4 and P3 already having that 4. So but the arrival time of P1 was earlier, so we take P1, and if suppose this arrival time was same, then we have to look for that is smaller IDE. So in that case, P1 will get priority. So, but we have here 0 is arrival, which is earlier arrival for P1. So we will take P1 into consideration. P1 6, then P1 7, 6 to 7, like that. So here is P1 5 to 6, and then 6 to 7, then P1 7 to 8, and then P1 8 to 9. So rest 4 units completes for P1 process, and P1 completes its 5 unit interval time over there in CPU. So it will exit, and finally we left with only one process P3, and this having that first time equals to 4. So P1 having this 4, so directly we can write 9 plus 4 13. So this is the way this Gantt chart has completed. Now we have to compute completion time first. CT in short I have written. So we have to just look for final completion time of each process. So P1 having that 9, P1 having 9, and P2 having this we have to look for P2. P2 having 4 here. In that case, P2 having 4 completion time. Then P3 having this, you have to look for that 13, and P4 having 5 because here it runs for this time duration, so it will be having 5. So this is the way you have written with the help of the Gantt chart. You have written this completion time of each process, and now you have to find out turnaround time. So turnaround time is nothing but it's a CT minus AT. CT stands for completion time, AT stands for arrival time. So turnaround time for each process look like this way. Even having 9 completion time, 9 minus this is the arrival time. So this is 9 minus 0, so it will become 9. Then P2 having completion time 4, and this is having arrival time 1, so it becomes 4 minus 1 3. And then P3 having completion time 13 and arrival time 2, so it will become 11. P4 having completion time 5 and arrival time 4, so it will become 1. So this is the way our turnaround time will be found out if we just verify 9 3 11 and 1. So this will come out to be, and then next we have to find out after turnaround time, completion time minus arrival time, we have to find out waiting time. So if you want to make average of this, you have to simply add all these values 9 plus 3 plus 11 plus 1 and divide it by total number of process. So total number of process, actually we have 4, so divide by 4. So make sum of all these values divided by 4. You will get average of each of these time that we are computing. So waiting time is nothing but it's simply is turnaround time minus burst time. So we can compute this as well. So waiting time P1, P1 having turnaround time 9 and burst time 5. So 9 minus 5, 4. Then for P2 having turnaround time 3 and burst time 3, 3 minus 3, 0. Then P3 having turnaround time 11 and burst time 4. So it will be 11 minus 4, it equals to 7. And P4 having 1 minus 1 equals to 0. So let's I verify this 4070. 4070 is a digit. So if you want to compute average of waiting time, you have to just add 4 plus 0 plus 7 plus 0 divided by 4. Total number of process. Next is you have to find out response time as well. Response time first appearance in CPU. in CPU and minus arrival time. This is that response time that we have. So P for P1, look for first appearance of P1. So this is at 0 and arrival time was 0. So it will be 0 minus 0 equals to 0. P2, P2 first appearance is at 1 and arrival time was 1. So 1 minus 1, it again 0. P3, P3 having first appearance at 9 and arrival time was 2. So 9 minus 2, 7. And then P4. P4 having its appearance at 4 and arrival time was 4, so it will be 4 minus 4 0. So let me verify that. So 0070, 0070. So this is the way you just compute turnaround time, waiting time, and response time. So just practice it because these are important numericals for your university exams as well as for the competitive exams. Thank you very much being with me in this session. Please subscribe my channel and press the bell icon so you may get the notification of the latest uploaded video. And please go through German language playlist as well because those lectures for A1 and A2 certifications of German language. And thank you very much. Your suggestions are always welcome. Have a nice time ahead. Thank you.